The other important thing is the sampling pattern we use. And this shows an example of all of the types we can use, and we'll go through these one by one. This would be a random sampling pattern. So we just have an area here and we put random samples throughout the area. And even though this is not evenly distributed, there are some places here that have no samples at all, such as these areas here and here. And sometimes the samples are fairly close together. Overall, and especially if we have no additional information, random sampling actually works pretty well, assuming we get to that the total number of samples we'll need to represent the population as a whole. Another method is systematic sampling. So we could just take samples every 10 meters or 20 meters or 30 meters apart in both directions here. Systematic sampling is good. The one issue with this is if we have some sort of linear grid, like a road network that cuts between where our systematic samples are, we might miss that completely based on what the patterns are of the road network and what our systematic sampling does. So in this case, actually a random sampling might be more likely to hit a road than a systematic sampling. Another type of sampling to use is a stratified random sampling. So in this case here, the first thing that we do is we come up with some sort of stratification of what we're going to sample. And this could be by the classes or the categories that we get out of our remote sensing image classification interpretation. And then we take samples within each of those classes or categories, which ensures that even ones that take up small areas will have some samples associated with them. And so this can be another strategy, especially if we're having problems sampling some of our classes of smaller area with our sampling scheme. And another type of one is the stratified systematic sampling. So the first thing that we do here is that we stratify the area by putting in this irregular grid here. And then within that grid, we put in these other points here to represent samples within each of these quadrants of this sampling technique. So this can just kind of break it down in one way and then further break it down randomly within these boxes to kind of give like a two-tiered approach to sampling. One other approach is we already know where our items of interest are, represented by these central points here. We might want to cluster our samples to try to capture information around those points or around those areas there. So this could either be used for points, such as is shown here, or for linear features, such as a stream or its associated riparian habitat. And we could kind of target those areas by clustering our samples around either point or linear feature in order to ensure that we're getting samples that are close to or right on these features that we're interested in sampling.